So in this video we're going to be looking at the AQA GCSE additional physics topic of forces and terminal velocity. To start with, we're going to think about falling objects, and my example here is a base jumper who's just jumped off a building before he opens his parachute. And he is affected by two different forces, the first of which is weight. And this may seem a little unusual to you at first because we don't usually think of weight as a force, but it is, and it is measured in newtons. And it's a downwards force created by an interaction between the mass of the object and gravity. So the weight, being a downwards force, causes him to fall in this direction. But weight isn't the only force which interacts with our parachuter. He is also being affected by air resistance, and we've talked about this before, but for those who don't know, it is a frictional force, and in this situation it opposes the direction of gravity and the force of weight. So therefore it is found in this direction. And together the weight plus the effect of air resistance equal the resultant force, which we looked at in the first few of these videos. I've now got a velocity over time graph which show the different stages of falling. So you can see as an object initially falls, its velocity is very high, and this velocity slowly decreases until it reaches something called terminal velocity, which is the maximum speed in which an object can travel. And I'm going to use a different example to explain this graph. So here we have a coin being dropped off the top of a building, and at this stage the coin has just been dropped. So it is in this part of the graph, the first stage, in which the increase in velocity or its acceleration is steady. It is steadily accelerating because its weight creates a downward force, and its air resistance at the moment is almost non-existent because it hasn't reached a high velocity yet, because air resistance increases as velocity increases. So as it's falling here, most of its resultant force is a downwards force. At this part of the graph, B to C, we can see that the velocity is no longer increasing and starting to level off. And this is because the air resistance, which is a frictional force, which acts in the opposite direction of gravity as we know, starts to slow the rate of acceleration. And although the resultant force is still in favour of the weight, so is still causing the object to drop downwards, the air resistance has started to increase, although it isn't as strong as the force of weight. And finally, the weight of the coin and the weight of the air resistance become balanced, and this is at this point in the graph, terminal velocity, which is where the velocity no longer increases. And this is because the resultant force is zero, and it stops accelerating. I hope this video was helpful. Thank you.